Alrighty, so we're going to continue to practice. So you can go back between slides to reread the different descriptions of these shapes if you need, or if you can visualize it in your mind, that works great as well. So a rectangle. So try and envision a rectangle in your mind. So it has how many pairs of parallel sides? So if we envision a rectangle, I'll draw a quick one right here, okay, it has this set of parallel sides and it has this set. So it has two pairs, oops, two pairs of parallel sides. And then equal length, okay, this side is equal length with this side, and then this side is equal length with this side. So it has two pairs of sides that are of equal length. And then if we think to the corners, it all makes those L-shaped corners. So that makes that exact 90-degree square. So this has four right angles. Okay, now a rhombus. So we can even scroll up because we know figure C here was a rhombus, just to refresh your memory. So a rhombus has how many pairs of parallel sides? So if we picture that, and we can use this one as an example, these are parallel and these are also parallel. So again, this has two pairs of parallel sides. Okay, now if we go back, it has to have all four sides equal length. Okay, so four sides equal length. And then how many angles? So if we look back, it has four angles. All right, now a trapezoid. A trapezoid was also the ones we did up here. We have B, D, and F all as trapezoids. So a trapezoid has how many pairs of parallel sides? So this one's the one that kind of sets it apart. Okay, it only has one pair of parallel sides. Now, it also has some angles, but how many angles does it have? Let's go up here. Okay, so it has four angles, but sometimes a trapezoid has right angles, and how many are those? So remember, right angles, you're looking for those squares, so it would have two right angles. All right, now a parallelogram. So this is one that this name should kind of help you remember, a parallelogram. Okay, it has two pairs of parallel sides, and it also has two sides that are of equal length. So this and this are great examples. A and E are both great examples of parallelograms. It has those opposite sides are parallel. These opposite sides are parallel. And then it has two pairs of sides that are equal. So these sides are also equal. These sides are equal. These sides are equal, and these sides are equal. So both of these are parallelograms because of that. So they have two pairs of sides that are parallel and are equal length. And then they also just have four angles, right? Just nothing that is a right angle. They're all just regular angles there. All right, so now some true or false. We'll really test our knowledge here. So on, let's see, slide 21, when you're doing your practice, I included a Venn diagram here that will really help you. So feel free to go back and to use that when you are completing your own practice. Oops, I went too far. So a parallelogram is not a square. So if we think of square, a square has four equal sides. Parallelogram, if we go back, does not. So you can kind of use this to guide you, although a square is not there. So this is true. A parallelogram is definitely not a square, because something we need to kind of straighten out is there are going to be some shapes that can be considered another shape, and as long as it follows the rules, then you will see why. So a square is a special type of rectangle. Now, if we think back to a square, square has 4 equal sides, it has 4 right angles, it has 2 pairs of opposite sides being parallel. Okay, now the only difference with the rectangle is it has not all sides being equal. So a square technically can be a special rectangle. A square can be considered a rectangle, but a rectangle cannot be considered a square. So it can't go one way or the other, because if we think of a square versus that rectangle, okay, obviously my pictures aren't super great, but 4 sides equal. This has 4 sides, but they're not equal. Opposite sides parallel, opposite sides are parallel, opposite sides here are also parallel, and then 4 right angles. So you can see why it works. A rectangle may or may not be a square. Now this is true because a rectangle may or may not be a square. It depends if it has all of those sides be equal. Now finally, a trapezoid is a parallelogram. So if we go and compare trapezoid to parallelogram, this is false because trapezoid only has 1 pair of parallel sides where a parallelogram has 2. The trapezoid has 4 angles. It can have 2 right angles. A parallelogram will never have right angles. So this is false. So a rectangle has 4 right angles, and we should know this because this is what we just talked about on the last one. This is true. And then a rhombus has 4 equal sides, okay? Rhombus and square both have that in common. That is true. And a parallelogram has only 1 set of parallel sides. This is false because remember, parallelogram, we want to remember that it has 2 sets of parallel lines, okay? That's an important one to remember. All right, so combine the polygons on the left to make other polygons and figures. So we can break some of these shapes apart in order to make other shapes. So if you've ever used tangrams, you can think of the different shapes and stuff that you can make with that. So they broke up this parallelogram here by having a triangle, a square, and then another triangle. So unfortunately, since we aren't in school, we won't be doing the tangram activity, but if you have tangrams at home, you can definitely try that and test it out. So this is your Let's Practice that you will be completing. So you have 2 pages, page 1 of 2. So you're answering here, yes or no, and then use the figures here, figure A, B, C, D, and then complete the table. You do your best with spelling for the names, and then numbers of sides, angles, and vertices, and then go on to the next page. So this is the second page, the one that I showed you before that has that Venn diagram at the bottom. So these are kind of like riddles. So you're trying to figure out what they're talking about. And then the last one, you're just circling your answer, okay? Use this Venn diagram to help you if you need, or go back and forth between the slides to help you. Raise your hand on both slide 20 and 21 when you finish for me to check. And I will be sharing with you a tangram puzzle page that you can try and do what we talked about on the previous slide about splitting shapes up here and breaking up these different polygons. So this is, the tangrams is going to be an optional activity. It may not work on your iPad. You may have to do this on a desktop. I will check it out. But if not, I will try and look for another one that I can send for you guys. All right, take your time, read over these shapes, and don't get overwhelmed. It's a lot of new material, okay? So we will be practicing this all week. Good luck.